Dear students, today we learn the two important applications in motion in a straight line. First one, an engine of a train passed the electric pole with a velocity u meter per second. At the last compartment of train to cross the same pole with a velocity v meter per second, find the velocity which with the midpoint to train past the pole, assuming the acceleration is uniform. So according to this application, I will draw the diagram. So this is a pole, let it be. A train cross the pole with an engine, this u meter per second. At the end of the train, let us assume in the straight line. So this is v meter per second. So we need to find the velocity at the middle, right? So this, let it be engine u meter per second. This is v meter per second. We need to find the velocity at the middle here, vm. So let it be assumption of this, let it be a, b and c. So the length of the train you can consider L. So this part is what? L by 2. This part also L by 2. So acceleration is uniform here. First I will take a to b. A to b from the equation of motion v square minus u square equal to 2as. So final velocity a to b, what is that? Vm square minus u square 2 into a into displacement how much? L by 2. So here Vm square minus u square 2 into 2 to cancel, that is a into L here, let it be equation 1. So now again you take b to c from the equation of motion v square minus u square equal to 2as. From b to c, this is final velocity and this is initial velocity. So what is the final velocity? V square only. Initial velocity Vm square 2 into a only, s is L by 2 here. Then 2 get cancelled. V square minus Vm square equal to a into L, let it be equation 2. So now from equation 1 and 2, AL and AL are equal. So this is Vm square minus u square equal to v square minus Vm square. So you can transpose the Vm one side, Vm square plus Vm square, that is equal to u square plus v square. So 2 Vm square equal to u square plus v square. So Vm square, that is u square plus v square by 2. So finally mid velocity v equal to under root u square plus v square by 2. So this is Vm here, mid velocity, u is the at the engine velocity, and v is the final bogie velocity. So hope you understand this first application, right? We'll go to the second application. So therefore a car starts from rest, travels with uniform acceleration alpha for the some time, and then uniform retardation beta comes to rest. The total time for this t, the maximum velocity and displacement we need to find. So for this there are two methods are there. First one is graphical method, I'll explain. So graphical method. For graphical method we have to take velocity time graph, vt graph. So it starts from rest, reach the maximum velocity, and then retardation here. This is acceleration, this is retardation, this is the maximum velocity 0. So the total time interval is, let it be take t here, total time interval. So for this time, for let it be t1 here. So for an acceleration formula alpha equal to v max by t1 here. So from this v max velocity alpha t1, let it be equation 1. For retardation for retardation in the graph, beta equal to, you can take Vm by total t minus t1 this time, that is t minus t1 time. So then Vm equal to beta of t minus t1. So this is equation 2. So from 1 and 2 Vm are equal. So then you write alpha t1 equal to b into t minus t1 here. So therefore alpha t1 beta t minus beta t1. So t1 you write one side, alpha t1 plus beta t1, that is beta t here. So now you can common t1 here, alpha plus beta, that is beta t. So then t1 value what it comes, beta t by alpha plus beta. Now this t1 value substitute in equation 1, will get maximum velocity at maximum velocity Vm from 1. Vm value what, alpha into t1. So alpha into t1 value beta t by alpha plus beta. So final formula alpha beta t by alpha plus beta. So here Vm is the maximum velocity, alpha acceleration, beta retardation, and t is the total interval of time. So again displacement here, displacement will get area under Vt graph. Area under Vt graph will give the displacement here. So displacement from the graph, area of triangle. So what the area of triangle here, half base into height. Half base how much, total time, height should be Vm. So you can write half t into Vm value. What is the Vm value here, see, alpha beta t by alpha plus beta. So finally displacement S equal to alpha beta t square by 2 into alpha plus beta. So this is the displacement covered. So one more method also there, that is analytical method. So we'll do that analytical method. So for analytical method, from the question, it starts from rest, it's moving with an acceleration alpha to reach maximum velocity, then retardation, and comes to rest, final velocity 0. So here you take a to b acceleration, b to c retardation, this time interval t1 a to b, b to c t2. So write for a to b, apply equation of motion v equal to u plus at. So what is the final velocity a to b, Vm, initial velocity 0, a is alpha, t is t1. So Vm equal to alpha t1, then t1 equal to Vm by alpha. So this is equation 1. So then write b to c, what happened, retardation will happen again from equation of motion, v equal to u plus at, final velocity 0, initial velocity for this Vm minus beta retardation negative t2 here. So therefore Vm is beta t2, therefore t2 equal to what, Vm by beta. So this is equation 2. Now total time t equal to t1 plus t2 here. So what is the t1 here, Vm by alpha, Vm by beta, that is total time. So here t, Vm common here, 1 by alpha plus 1 by beta. So take LCM alpha beta, Vm equal to Vm alpha beta by alpha plus beta for LCM this. So finally do cross multiplication, Vm equal to alpha beta t by alpha plus beta. So this is the maximum velocity. So again displacement also there, displacement formula S equal to Vm by 2, average velocity into time formula is there. So Vm is nothing but a alpha beta t by 2 2 into alpha plus beta into t here. So final formula S equal to alpha beta t square by 2 into alpha plus beta. So this is the displacement and maximum velocity in analytical method. So here alpha is acceleration and beta retardation and t is the total time here, So hope you understand. Thank you.